How are you doing, guys? I'm back for my thesis. We are going to work on my thesis. Last time I told you about the dynamical system, about the diagram, about pricing, about quality, about rating, about score, about buying a sponsorship, about advertisement on other platforms, about putting the slide on the chat GPT and getting the code, and we were fixing the code. Let's do it. So ring bing, control shift 2. So first time used NP, numpy as NP, stands for Nuripur, alpha 0.5, P1 0.9. P1 was the odds of being shown when your score is higher. Gamma was the coefficient that when we are comparing a small scores and gamma is the coefficient that should be multiplied by your buying a sponsorship. It is the effect of a sponsorship. That's it. Gamma is the effect of your sponsorship as the firm. Yes, we are not consumers here. We are producers. np.array 0.7, 0.6. Okay, this is the quality. This is the first price. P is the vector of price at time 0. And then we had like a, now I remember, we had like, I was trying like a bitch why Python is so difficult for working with arrays and we should have a lot of brackets. We are done with that. We cried like a bitch once. So whenever we want to cry again, just go watch that video. We are not crying no more, at least for a while. bnp.array, what was B? Buying a sponsorship or not? Well, it is a one row array. Later we will make it like a strategy and see how it works. And for now, let's just calculate new scores at time 2. You know my background, I want to start my time from 0. I started from 1, like any wise person would do. YBT is B. What is YBT? Well, I don't like that. RT is Q minus P is the rating or the feedback they gave to system. So we don't need that, huh? I think I don't need that. Calculate new scores. S1 new. Okay, S1 new is good. Is alpha times S0 plus P1. Does it match? S1 new is T plus 1 alpha S0. Yes, by S0 we mean not at time 0 but the, so that's okay. P1 S0 plus gamma B1 B0 S1 gamma B1 RT0. Where is RT? Okay, RT0. Well, we don't need to have RT, by the way. And also I don't like the fact, or is it just first time? Okay, no, it's okay. R can be R, and we have you will be shown by probability P2 if your score will be plus the sponsorship effect is less than the other person. What is this? And la 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 la, killing my so what we are going to return is np.array s1 new, s2 new, sounds good to me. And then we are putting it, the function, in a for loop to create us columns. To be honest, I preferred to have a column vector, and then time is something horizontal for me. Time for me is horizontal. Maybe later, not now. Simulate the recommender system for a few time steps. S is a speed dot append. Oh, okay, we are dot append. We are using dot append. Okay, we don't need this one no more. And here was that we started seeing, like, working with, you know, with the brackets. So here we can see that we are returning a vector, a row vector, and S is already a row vector. So we want to put it below it, and S is just the calculate new scores, alpha P1, P2, SQ, PB, access 0, num type step, time steps. Sorry, I don't get this part. Oh, okay, for time step 1, we already did it. We append it. Why? Because, oh, okay, now I get why, I remember. For the first time step, we did it outside the for loop because there was problems. The code, difficult to differentiate between a vector and a matrix. Now that we are doing it outside the for loop for the first time. Inside the for loop, we will have matrices. So ST, and what is ST? ST is the score, which we need only the score at the previous time step, which is fine. But what is ST? Is it a vector? When I say vector, or is it a row vector, or let's see. Okay, so, and I don't remember what was wrong with this code. How can I delete this? Why is it Python 3? Oh, okay, that's good. Delete cells, Control D. No. Okay, never mind. DND, what is DND? Command mode. Oh, we deleted, but D. It's deleting. All right. Okay. Oh, I should press D twice, sorry. Let's run this. Okay, we have problem in concatenating, which means penetrating an array with another array. So it's a dimension problem, as I is written here. Okay, what is wrong with this code? We know what is wrong with this code. We are going to use our superpower. Why? I won't touch my phone. It's here. Interesting. If I bring it here, you cannot see it, but if I bring it here, you can see it. Conditional expressions. What is the conditional expression? Oh, if. Oh, the comparisons. No, it's not true. What was wrong with my code? No, that's bullshit. He's just saying putting parentheses here. No, dog, it is not. Nope. No. No. The problem. You're not right. You're wrong. Here's there.
The error indicates that there's a dimension mismatch when append.
Oh, and now I remember what was the problem. Problem was we were generating these new vectors, and our S is like this, and what we wanted to append them like this, stack them like a column, but the guy who had the code was putting them next to each other and just making a row vector, which is not what we want. Oh, we can use np.concatenate. How so? Okay, I before doing this change, I will try it out on my own. Let's say A is NP array, right? A is NP dot array should put 0, 1. B's NP dot array 2, 3, right? And now if I say B 0, what is B? Right. Now I wanna append. Okay. C equals np dot append A and B and access 0. Let's see. Okay, that is the mistake. Okay, so we should choose access as 1. What? What is wrong? I see. How can we concatenate? Should we do that? How to put 2 np dot array of a size 1 times n on the top of each other. To have an np array of size 2 times n. That is what I want. NPV stack.
To stack two NumPy arrays of size 1n on top of each other.
Beat. What is this one? No, auto. That's it. Okay, with stack function, here is how you can do it. Array 1, array 2, there is stack. Oh, and he uses parentheses. Is there a way to do it by dot append method? So okay, we start with thin. What is reshape? to have a single row. They have a single row. Okay, fuck that. We are using VStack. np.vstack. I feel I don't need to put these brackets. Same, no access, and again VStack. Actually, we don't even need that. Just how do you feel about this, guys? I say let's try it. And it's blue, it's on the command mode. No. All right. Oh fuck. Takes one positional argument, but two were needed. What? No. Oh, we should put all of them in parentheses. Honestly, this is not my fault. This is the code having problem. Like the language. Why should we do it like that? Maybe it is the way it works. I get it. Okay. Interesting. What is this 0.29? Their score. So at the beginning, time 2. Well, what is S? Show us S. So starts half. Why? Okay, because it was half. Why do we have so many rows in S but not? If it was 6, it is 7, which I don't get. Okay, 7 from 1 to 5. Exactly. So I don't get this part. T is 1. Print T. That is good. Why don't we have scores of 10 generated T? So T goes up to 5 and doesn't turn into 5. which is true, which is okay. 1, 2, 3, 4. Wait, does it change? 4, 4. Yeah, okay, this is not the code. Like, yeah, he's adding it. Every time I call S, it's getting bigger. Why? Why should it be like that? No, it is the same. How many rows? 1, 2, 3, 4, 5, 6, 7. So I was bullshitting. Yeah, it is always 7. But why is it 7? I don't get it. No, it's 8 now. Okay, S size. Tab. S is an int. Size of the size of how to find size. Okay, there is no. What's that size? 16. I play this. Oh, why weird? Why is it 16? It's so weird. I see. Okay, do you get it? The reason is that the input to the algorithm is now S. What is S0, S1 now? What the dumb fuck it is? S0. So how do we do the computation? So when here S is a column, like a matrix, we give it to the function. He's trying to compute the newest scores, right? But I don't want to touch this. It's going up, right? When we say S0, it takes the first row. And we say for S1, it takes, and let me show S1. It will be 0.29, 0.43. Yep. Yes. The strange thing is that how do they do those comparisons? For this line, alright. How do they do the I should not sit like that. How do they do the comparison? This is a weird comparison. I don't get it. Do we have vector comparison in Python? Seems like that. So what we want is st here, not s. Actually, st minus 1. Yep. This one. Every time I... What? What's wrong? Where is there? There is nothing wrong with it. Let's something ss equals s t minus 1, and then s on this part. Okay, same problem. SS. So what is wrong with it? What is wrong with it? Invalid index to scalar variable. Why? I'm telling you, print s. Do that and we will see who is wrong. Print s. And I want you print s0, which will be ss, right? And I want you print s1. So when ss goes to the function, it's just going as a number, not as a vector. And why is that? It's weird. Here ss is... Oh, ss is a number now. Why is it a number? S is this. SS... Ah, I got it. Fuck. Because S, first time S will be... Yeah, can I do that? The same thing. 0, 1. I say a 0 0 fuck. Oh, I see. Okay. What if I say this? That's fucked up. Well, it's not so like complicated. We can do this. So here we don't need SS, so just S is enough. Then you need to put S, and first one I don't want it, so why is okay. Starts from 0, which is true now, it's okay. Isn't it true? That's it. Who said you? Why is it printing? I don't like that. Oh, okay, because of that. Sorry. Also, the numbers changed. So, how was this story? The story was that first player. Oh no, okay. Higher probability of being shown is 0.9. At the beginning, they have same scores. The difference is that quality. Okay, data buyer firm 1 has a higher quality and lower price, right? The difference, the rating at the beginning, his rating at the beginning is 0.4. His rivals rating at the beginning is 0.2, but firm 2 buys sponsorship, which has a great factor. Look, we had rating plus gamma times buying sponsorship, right? So gamma here, sponsorship is the bigger factor, and we can see that over time both of them they are losing score, but it doesn't matter because I feel data buyer firm 2 doesn't care about his score because he's buying sponsorship all the time, so he doesn't care if his score is low. However, his score will be higher over the time. Will it? Well, we have alpha, which is half size of your previous score. The effect of your previous score is not much. And you have your rating, right? What is your rating? 0.2, which should be multiplied by P1. Will be 0.18 plus, yeah. So scores are going down, but it doesn't matter. He's winning all the fights. I guess. Print. Should be all 0, I guess. False. All of them are false. What happens if I don't leave a print? But what happens to this line? Nothing? Interesting. Oh, he does the computation and says that. Fun. Now let's bring the effect of a score lower. Also, now let's have their income out of this game. La 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 la. Guys, we are doing good, guys. Yeah, we got the code done. It's giving us intuition. I like it. And we are keeping the bidding strategy simple. One buys bidding, one doesn't buy. Especially the one who is lower quality, higher price is winning, which is something the platform doesn't even. If we talked about these social platforms, their revenue comes from pay-per-click. If as a firm you buy the slot and your product is sold, then you're paying the platform. So platform doesn't want it. Like winning the second firm, lower quality, higher price, winning is not necessarily beneficial to the platform. So let's do it one more time. Still, second dude is winning. One more time. Well, first time, um, always first time, that's because we started from 0.0. Is that alright? By the way, maybe later we want to put a Bernoulli variable instead of P1 and P2. That every time happens randomly, but let's not do it for now. Interesting. Why so? First time, Bayero 2 wins, no problem. What is R? Oh, R is Q minus PL, which is true. But R has no effect on S, which is right. It doesn't? It has. It should not be S. It should be R, right? Oh, you're rating here. So your rating affects next rating for sure. For the first guy it is 0.4, for the second guy it is 0.2. He loses, first guy loses, second guy wins. 0.9 times 0.2, 0.18. Yeah, I think the gap is too big. It's about the starting point. So if he buys a sponsorship, isn't it interesting? If he buys a sponsorship, the first guy, right? First guy starts to buy a sponsorship, and even though the quality and they start at the same time, their quality, both of them are half-half. The lower quality guy, higher price guy wins all the time. And what if you what if it's not like that? It's just say 0.7. He has a better score. He just came to the game. Now he's winning all the time. What if I increase the time step? Oh, okay, gamma is too low. What if I increase the number of time steps to fucking 10? Still all true. Whatever sponsorship, however you buy a sponsorship, it doesn't matter. Why? Because your B0 is 0, 0 is something. P1 plus alpha, you can see P1 plus and R0. P1 is 0.9, R0 is Q minus P. 0.4, 0.9, 0.4, 0.36 plus alpha, which is 0.5. So it will be 0.86 at most. Oh, 0.86. Oh, it's not. What if I say 2? 2, make it 2. 5. Okay, too big. Sponsorship is winning, they call it. Okay. 3. Interesting. 4. 4, 5. Okay. For 25. Too big. For 1 to 5. Still all false. I want to see a switch. What if I make it 20? Is it like that? Interesting. 0.2. Three. What number was it? 5? What the fuck? I think I lost the. So gamma helps data buyer 2, firm 2, and we are saying when. Oh, okay, so firm 2 is winning here when we have false. We should bring it low. 4. Okay. 4.05. Okay. One. No. Interesting. One. Fuck you. What is the difference? Is it the number? Is it just a number that the solution is gamma? I guess it is. Like it's a switching point. Interesting. Either one of them wins all the time, one of them loses all the time. Ain't it funny? What if okay, no, it's not true. I want to see a switch. Okay, nice. First guy is winning, first guy is winning, first guy is winning. I lost the direction. Alright, fuck it. You have the code. The code is working. So what are we interested in? We are interested in pricing, we are interested in quality, we are interested in buying a sponsorship. These are the questions I am interested in, right? And I want to do simulations for them. And then plot them. And there are extreme cases, right? We are not changing the price, we are not changing buying a sponsorship, and quality is no. So let's set some goals for the next time. It was cool. I like this. Effect of buying a sponsorship, right? So, okay, one, now that we managed to do this code, one, reading a new paper on advertisement / recommender system. Systems. Two, on the code. One, we want to see one effect of not one, a effect of buying a sponsorship. So we are interested in sponsorship, we are interested in score, initial the scoring at the effect of a scoring at the beginning, initial point, well, starting point. We are interested in quality or quality pricing rating R and sponsorship trade-off, and we are interested in expected revenue of the firms. Maybe we want to try using a Bernoulli variable instead of P1, P2. Whew! Done. That was good, guys. We had a good conversation. Okay, Control Shift. Have a good night. I will come back with yeah, let's do some more coding. I say that's very good. My project is coding now. We are working on coding separately. Feels good. Let's do another coding, and hopefully we can make also one about machine learning.